Hey everyone, today I'm going to be talking about demystifying the applications of natural language processing across several different industry verticals. Before I dive right in, I want to quickly introduce myself. My name is Jyotika Singh, and I work as a director of data science at Placemaker, which is a tech-enabled, flexible hospitality living platform that blurs the line between hospitality and home. I've also attached my social media handles here for reference. So in case anybody has any questions and that you're not able to ask during this conference or later on, you can feel free to reach out to me on Twitter. I'll also be posting the slide deck after the conference on Twitter. Uh, Secondly, I want to mention that natural language processing is all around natural language, which is not just text. It's also speech, how people speak. But that is often, less talked about compared to text. It's just text has large amount of wider applications and processing in place. But in efforts to have audio processing availability in open source, there's a library I created a few years ago called Pi Audio Processing. So just wanted to link this out here as well, if you're interested. So diving right in, before we get into applications of natural language processing, what is natural language processing? So firstly, it's around language, and natural language is the term that we define here, which is the language that humans use to communicate. And as you know, there's a lot of history behind it, how language has evolved. It contains so much diversity. Everybody has different speaking styles. There are so many different languages out there. And also the evolution with time. So for example, abbreviations like BRB, LOL, they were not at all prevalent in, about 10, 20 years ago, 20 years ago. And then with humans using such abbreviations in language, this sort of came up more and more in usage. So this language just evolves in time. So that's why it's a little bit tricky. Natural language processing is considered challenging because of the evolution, different styles of the language. And natural language processing is essentially the computer's ability to understand this language. So from anything as basic as a program that counts word frequencies in a sentence to actually understanding what a user is saying and replying with a relevant response. So all of that is like the umbrella term that defines natural language processing. So today what I'm going to be doing is we're going to be talking about these 5 different broad industry verticals, and we'll be just discussing what some of the applications are that you may have seen across these that actually use NLP in the backend. And then after that, we'll take the 2 very commonly occurring applications, and we'll see how possible implementations using Python look like for these. So to get started, let's talk about e-commerce. So what is e-commerce? It's just buying and selling of goods and services via the internet. Just for the industry perspective, there are a few different types. There's a B2B, a business-to-business perspective, such as Shopify, where businesses are selling to other businesses. There's a business-to-consumer segment, which is something like Target, Amazon, where businesses are selling to consumer. Some also like to define it beyond these 2 categories and include consumer to consumer as a category, such as eBay. So where you may have seen NLP, let's look at this example. So you're on Target and you're searching for tumbler, but you enter the wrong spelling. It still is able to recognize what tumbler you're looking for. You click on one with the straw. And then you see in the more to consider section, you see a lot of other tumblers, and a lot of them seem to have straws. So it's like a feature that that was a part of the tumbler you clicked on, and you can see that is in the more to consider section as well. So like the product recommendations you get. Let's look at another example of things that you may have seen when shopping online. So let's say you're searching for formal pants. You click on a product. Now, as you know, there are a lot of reviews, customer reviews that help you understand how other people feel about the product. And some are categorized by the user. But then there are also other categories that these platforms offer you, such as fit, color, where you're able to filter the comments and look at the ones that are actually concerned with fit. Now, the user that is typing the comment is not necessarily doing that. They're not categorizing their comment as, yeah, I'm talking about fit and color. They're not. So what happens is in the back end, all these comments are getting processed and categorized into relevant categories that then is able to be shown to the consumer so that you're able to filter to the aspects that seem relevant to you. So those are a few examples that you may have seen. We spoke about comments classification. We spoke about intelligent searching, where the typo correction is a big part of how things get done. Another application would be product recommendation, which we also saw in the previous slide, all the Tumblr recommendations that we saw. What happens is every product has this text description, this rich text description that lists a lot about the product. So able to match that to other products in your database. And also, if you have consumer history present, so which consumers may have visited a particular product and another one after that, like in combination. So that's sort of an approach as well. Language translation is an important one for this industry too, because some businesses are just set globally and they want to be able to offer their website, their services, their products to different users across the globe in different languages. Customer service analysis is, again, a very important segment where, how you have these chats and calls with customer service. And you often see they're saying, well, this call may be monitored or recorded for quality and training purposes. So that is, one application of NLP as well, where all this rich amount of data, any chat data, is analyzed to understand consumer behavior and how responding to a consumer may set a business's better customer service practices. Furthermore, there are chatbots, which are customer service solutions. What chatbots are is when you're chatting on any such platform, in some places, which is getting more and more common, where when you start the chat, it's actually not a person on the other end. Sometimes it may seem like it's a person on the other end, but a lot of the basic type of questions can be answered by an automated service behind the scenes, which is called chatbots. So these are essentially bots that are chatting with you. The very common application and essentially reduces the load on the customer service to handle the kind of volume of requests that they're typically able to. Let's dig into finance. Now, it's essentially finance industry as a whole is just a lot of businesses that are dealing with managing money. So that can be banks, that can be stock brokerages, investment funds, and there are many other types like that. So now, when you think of finance, one thing that comes to mind is stock prices, right? So what happens is news in general influences each one of us. It influences people, we get information. So when the news is related to stocks, that also influences people, and specifically investors, people who are buying stocks and selling stocks. And then any decisions that investors take have an impact on the price of the stock trading on exchanges. So it can be a positive impact or a negative impact. One particular example, and pretty popular one actually, is this one time Elon Musk tweeted about using Signal. And what happened is that actually ended up leading to a surge in an unrelated stock with a similar name. So you see how a tweet essentially went on to that impact in these kind of areas. At a high level, the sentiment analysis is really important to understand how people are reacting to particular news, and that helps in determining any trends in stock prices as well. There's so much news and data on social media, for example, even if we consider tweets. So getting tweets that are relevant to your topic, to the topic that you're interested in, that forms a large application as well to classify these tweets or these news accordingly. Language translation is another one to translate financial services, documents, all of that. We've spoken about chatbots and customer service analysis in the past as well. So here they also follow the similar principle. The new one here is legal document review. Now, there's so many documents in that industry, and it's hard to sift through such a bulk. And that's why things take so much time in that sector. So there are a lot of companies out there forming these services where they have this database of documents, and it allows you to find relevant documents to your search query so that you can cut down on your manual sifting through time. And also other applications like document summarization, which is there's so many large documents, and being able to search quickly and fast. A document summarization, finding similar documents, these sort of applications are really helpful in the finance industry. Next, we talk about real estate. So in general, real estate refers to any property, right? So basically anywhere you are right now, that's a type of a real estate. The popular types include just land which has no building on top of it, empty land, vacant land. Then residential, where people stay, so apartments, condos, single family homes. Then commercial, such as malls, parking lots, offices, and then industrial, where people set up their factories and so on. So real estate is this broad term that just specifies or hints towards property, and the industry itself has so many different perspectives to it. There's developers, there's property management, lending services, brokerages, and so on. Just for an example, let's talk about Redfin, which is a full service real estate brokerage. So Redfin is a platform where you'll see there are a lot of listings for homes. There's like this map view where you can see what homes are available or out for sale or recently sold around a certain location. People can enter a lot of photos, descriptions. Then there are some specific fields that you're required to fill, which is how many bedrooms, how many bathrooms, square feet, the price. You can also schedule tours, find real estate agents. There's a lot of services provided here in this example. So one popular way NLP is used in real estate is that when there's a text description associated with a property, there are a lot of important information embedded in that, which form as key features or key offerings of the property. So to identify that is one very important or greatly used application. But also there are text descriptions, and there are sometimes fields that people fill out. And if there's a discrepancy, the kind of tool checks for that as well. So if you filled out 2-bedroom, but a description says 3, well, which one is it? So checking for that discrepancy, but essentially identifying this information that helps with the sellability of a property is a popular application. And it was reported that NLP analyzes hidden values from these text description, and that's actually led to an increase of the property value between 1 to 6% on average. There are a lot of other applications as well. SEO is search engine optimization, and NLP just helps with keyword identification and identifying these keywords that increase searchability of the property. We already saw an example of autofilling missing property fields in the previous slide. Other examples are GDPR and CCPA compliance. So what are these compliances? So CCPA stands for California Consumer Privacy Act. Essentially, these are if businesses comply with these, then they are required to ensure that they are not saving consumer data that they are not permitted to. So with CCPA as well, if I go on a website and I request for them to not sell my information, I can do that, and they need to remove my information. So now what happens is they can be storing my information in a particular way in their data set. And when I file that request, they want to be able to match me and the information I provide to the one in their database so they can clear it off properly. So assuring these compliances and using NLP, natural language processing techniques, to ensure matches is one application as well. We've already been through chatbots, so this one also follows a similar principle in this domain as well. Legal document review, also with real estate, there's so many documents associated. So the similar applications as we talked about in the finance domain. And then we have PII removal and detection. So PII stands for personal identifiable information. And a lot of businesses now, sometimes when you are filling out these descriptions online and inadvertently any personal information goes into any document that you're either posting or just sharing, and it inadvertently gets in place. Now it's very important to be able to make sure that the documents stay away from that, to just conduct safe operations. So detecting personal identifiable information like social security numbers or credit card, or your contact information even, like a phone number or address where it's not supposed to be within documents. Next, we talk about social media. So there's so many different platforms that we all know about and probably use very regularly. Twitter, Facebook, Instagram, LinkedIn, whatnot, really. So essentially, these are social networking sites where one can connect with other individuals and also post themselves content and engage with other people's content that they've posted. And when we talk about NLP, now we are looking at a lot of text data here. And where does that come from? So when even let's say you are browsing YouTube, now you may think of YouTube as primarily a video platform, which is not incorrect. There's so much text information that is available on the platform, from video titles, descriptions, to actually comments that people are leaving. There's just a rich amount of text information that is available on these platforms. There are different ways that these social media platforms themselves use machine learning and NLP, but also other businesses take the data from these social media platforms and analyze them to construct analytics, reporting, and insights off of the social media data. So one such example is this paper I've linked here, but with COVID, there were a difference in travel and flight searches that was seen between when compared to 2019. So between 2019 and 2020. So how that correlated with people and how they were engaging with videos around travel for the same time frame. And then what type of locations they were mentioning in their comments, what type of travel activities they were mentioning in their videos. So this is an example of analysis using natural language processing that other companies do that read off of the social media data. Where's a place that you may have seen natural language processing in action on social media? Let's check out this video. So you see the side recommendations there, like you clicked on natural language processing crash course, computer science. That's going to give you natural language processing, machine learning, computer science related videos in your recommendations. So behind the scenes in these recommendations, this text data that actually is used to describe these videos is widely used in creating these recommendations. So we spoke about content recommendation. There's a lot of customer support activities that happen on social media. So not just with social media platforms, but also what businesses do using social media. So you may have noticed that different businesses, for example, Expedia, you are able to chat with them using a Facebook Messenger, right? So they've actually deployed their chatbot on Facebook Messenger, and then you can interact there accordingly. In addition, there's just so much data that's generated on social media. Analyzing that helps businesses understand their customers and how they are interacting with any content that may seem to resonate with the product or the service that they offer. Sensitive content detection is a large application area from the platform's perspective. So they want to be able to detect sensitive content, fake news, spam, and treat them accordingly. So that's been a very widely applied use case where NLP has played an important role. Other use cases include comment analysis. So we have seen that a little bit in the past. So much data gets generated. So for content creators' perspective, understanding how their audiences comment on their content and what they're looking for, to how, from a business perspective, how people may be reacting to a video about a product or a service. And trend analysis, again, for businesses, as we saw in the previous couple of slides ago, how businesses use social media data to analyze trends. Lastly, we have marketing. Now, marketing is so broad. It's essentially refers to promoting and selling of products and services. And advertising is actually a subset of marketing. Marketing is all about, there was this concept about the 4 Ps: product, price, place, and promotion, which forms as an essential mix that a company needs to market a product or a service. Neil Borden popularized the idea of marketing mix somewhere in the early 1950s. But marketing essentially applies to most industries. If you have a product or a service, you want to be able to market that, advertise that, so that it comes to the knowledge of consumers and they're actually able to use your product or services. So let's consider an example. Definitely a lot of people would have seen this. So does it ever happen that you are actually searching for king bed frames on Google, and later that day or later when you open Facebook, you are seeing ads for king mattresses, right? So this is an example of advertisement, and anything from New York Times to part-time bloggers uh, can be, digital publishers essentially. And advertisers want to reach a desired audience, publish ads, and use ads to monetize their content. How this happens is using cookies and IP addresses, which are essentially text files in your browser that identify your computer's location and identify you. And that helps link your data across different websites, and advertisers can then reach you. However, this domain is slightly changing because Chrome announced that they'll be blocking third-party cookies by 2023, and other platforms would follow. So how essentially the tracking happens is subject to change. So that's one application. But when we're talking about particular applications of NLP in advertising and marketing, you want to understand your customer and you want to define your audience that you want to target. So anything from sentiment analysis, trend analysis, audience identification, topic extraction, anything that you can do to understand audience and create a service, product, or content for them follows under all those domains. Chatbots follow the same principle as some of the other verticals we saw. And another unique one here that has been, a little bit in the research is like AI-based slogan writing. So you know how it's so important to have like catchy slogans associated with products, associated with services. So using AI to actually identify these kind of slogans, potential slogans, things that rhyme, keywords that may be catchy or get hits. So now, we've seen 5 different industries, and we've spoken about at a high level where all you may have seen NLP, or if not seen, where all they may be using NLP in the back end, and what's really hot in the research areas. But now we're going to be talking about 2 particular applications that we saw that were occurring across industry verticals. So one of them is recommendation systems. And we saw recommendation systems. We saw an example in product recommendations, more to consider sections in e-commerce, social media, and then there's an application in marketing as well. Now, recommendation systems can be of 2 different types. One would be a content-based recommendation system, and the other one is collaborative filtering. Collaborative filtering essentially works on the principle that if I am watching a particular movie or interested in a particular product, then people who have also seen that product or bought that product, engaged with that product, what else are those people engaging with? And that will help predict what else I may like. So it's based on similar users and their practices. On the contrary, content-based recommendation system does not assume you have any information about other users, but it's essentially based on content. So if I am interested in this particular product and these are they are tumblers with straws, then I'm just going to look at that and find content or other products that have similar descriptions or similar attributes and description. We're going to be talking about content-based recommendation systems, since that's where a lot of the natural language processing aspect takes place. And as you can imagine, and as we spoke about, it's all around text, right? So the crux of the recommendation system that are based on context is that you find a way to perform text similarity. So consider any product or any content, consider the text there is a document. So we're calling it document X. And then we have a corpus of text document, multiple text documents. We want to see how X is similar to which one of the documents in my corpus. And those are the ones that are similar to my X document. So essentially passing the data through text similarity is able to measure the similarity between the different pieces of content that are text-based. Now let's consider an example. What we'll do is we'll look at YouTube data, which was crawled using YouTube API. how you perform a search on YouTube using the UI, essentially the same way, but using the API and using the keyword Python. We collected 555 video samples, and the problem statement is that you want to recommend videos similar to one being viewed. So essentially, from a backend perspective, you have one document or one video text, and you want to find others that are similar to that one. So there's definitely different ways that this problem can be solved for, and some of the popular ones are the three that I've listed here. So one is using TF-IDF or count vectorizer, which is essentially doing term frequency, inverse document frequency, seeing how commonly a term occurs in a document versus how commonly it occurs throughout the entire corpus, and adjusting the score accordingly. So what that does is the TF-IDF helps you get a numerical representation of your text. And then once you have that numerical representation, what you can do is you can perform a cosine similarity to get similarity between the two documents or their numerical representations. The higher the similarity, the closer they are to each other, and the higher is the text similarity measure. Another way to do that would be using word embedding. So there are a lot of different open source tools that are available for that. So one such example is Spacy. You can just get numerical representation of your text using Spacy. And then once you get the numerical representation, it's the same thing. You can do the cosine similarity calculation. And then the higher the score there, the more similar the text. And another more state-of-the-art approach that's been more popularized since 2018 is in NLP is transformers, specifically BERT, which stands for bidirectional encoder representation from transformers. Essentially a transformer-based machine learning technique for natural language processing, which was pre-trained and developed by Google. It was created and published somewhere around 2018. Now, BERT has inspired so many recent NLP architectures and training approaches in language models. So many improvements on top of BERT, some that give a better accuracy, some that give a faster performance with a little bit accuracy trade-off. But BERT forms as a great baseline if you're looking at transformers, and a good one to start with. Essentially, what this will give you is, again, this numbers, a way to represent your text, and getting cosine similarity between the resultant vectors is going to give you the similarity between the text pieces. So one other thing to mention is these are large models. And then there's smaller versions of these models as well that you can just use using open source tools. And these are actually trained on such large corpuses like the Wikipedia, entire Wikipedia, book corpus, and they contain like thousands of million words. So it's really based on a lot of large text representations. So in our example, we're going to be looking at two input videos. One is, remember, we search for Python on YouTube. So one is Python, the programming language, specifically machine learning tutorial data science. And the second one is actually about the Python snake. So ball Python bite. And we want to find other video texts that are similar to this one to create our recommendations for each of these videos. So let's look at the results. In the first approach that we spoke about, the TF-IDF and then the cosine similarity, for the first one with the machine learning, the Python programming language focus, we look at the top 8 scores there, the videos with the top 8 scores. And all of them look very relevant to, they're all relevant to Python programming. But if you were looking specifically for machine learning, not just Python, then number 7 is primarily Python, but it still counts as a good recommendation. It just depends on your use case, if that's not what you were trying to find. Same thing with Spacy. I think all are related to Python language, programming language, except for the 2 highlighted in yellow, which are Python programming language, but not machine learning focused. But the results overall do all seem very relevant to our input text. And now we're using BERT transformer, and we see the same thing. All are relevant to Python programming language. Just the highlighted ones are more the programming language, less machine learning. But again, all in all relevant. So those are not highlighted red, because red would mean that they are completely off topic, and it's strange to see that recommendation, or it may not be the business goal to see those recommendations. Now let's come on to the Python, the snake bit. So we run that through the same TF-IDF and return the top 8 with the best scores. And we see one of them is off. So it's actually around a snake game building using Python, but it's actually coming up in your in very high similarity score with the snake video. So that's one out of the top 8 there. For Spacey, it seems like all the results are related to the snake. So they all look good. And with Bird, it's also a little bit similar to TF-IDF in our case, in this particular use case. And we're seeing that snake game appear here as well. Now, if you consider that most of the videos are relevant, so it really depends on your use case of a recommendation system and how bad it is to have like one irrelevant content there, recommendation there. But all in all, the results for all three look good, and either of them could be a great option to start with. From a code perspective, this is how they look. It's really short pieces of code. Everything is available using open source tools. I will be sharing the slide deck, so if you want a reference to that, this code essentially, I'll be sharing that later. Now, you may wonder like which model to pick. There are 3 different ones that we spoke about, and comparative performance. So it really depends on the type of your data. So it'll be best to test your models on a sample of data set and see how they're doing in those manual tests that you conduct. Second would be computation time. So like transformer models are heavy, and especially if you want to do anything custom there, that can be requiring in both how much time, development time you put in there, and then also the computation time. So if you have any requirements there, if you want to use smaller open source tools that can get the job done, versus something that you have to build from scratch. If you do have the custom recording requirements, then you may want to consider building something of your own or using these open source tools as a framework to build on top of that. But just consider all these factors when you're making your pick. And sometimes it's not always the state of the art that works the best for every single use case. Sometimes classic approach, simple approaches also tend to work really well for a problem statement. So having that context would be great. Next, we go on to chatbots. So chatbots, as we saw, they're just so widely applicable across industry domains. And one of the primary use cases to have an automated customer service solution to reduce the load on your actual customer service team and get some of the easy things taken care of using a bot. So what chatbot is essentially a computer program that simulates human conversation, and they can be both voice or text-based. You may have also heard other terms, which are, again, all pointing to chatbots, but they can be called as, conversational app, conversational interface, and all those other terms that you see right there. There are two, at a very high level, there are 2 types of chatbots. One are very basic, more like rule-based, which are very simple. Example is like a decision tree. And it's very simple for simple use case, but they would lack the ability to answer unfamiliar questions or something that's framed completely differently, or with like negations. So there are limitations there, but if your use case is really basic, they can work for you. And the second example is the AI-based chatbots, which are of course more complicated. And there is this term called NLU, which is called natural language understanding. It's an AI hard problem, and it's a subtopic of NLP in AI. And what it does, it deals with machine learning, machine reading comprehension, and uses computer software using sentences in the form of like text or speech. So there are a lot of existing NLU services and platforms that can be leveraged as well if you want to build an AI-based chatbot, if your use case is more complicated. So let's see an example of each. So we're going to be looking at an example of a rule-based chatbot that we'll be looking at right now is something as basic as what you see on your screen. So your program there only understands 3 phrases. And if any of those 3 phrases, like take call, answer call, accept call, are detected, then it'll execute an action. If not, then it'll stop. So basic, simple, no logic, no AI in the back end. It's more of a simple chatbot there that you got. So let's actually see a sample of building a very basic one with very limited tool usage. and essentially just regex and NLTK. So what we'll do is we'll get synonyms for some of the questions that the users can ask. So in our case, it's going to be a chatbot that that gives the user an ability to say hi, say bye, and then ask for the timing of the store. Anything else, it won't be able to handle. So also because timing can be asked in so many different ways. People can ask what is the time of the store, or what is the timing of the store, or what are the timings of the store. So because it can be said in so many different ways, we want to build a list of synonyms for these kind of questions that they can ask. We want to identify user intent. So are they just greetings, like saying hi or bye, or are they actually asking for the time? And then depending on what they want, what's our fixed response that we're going to generate for them? So here's an example. Hello, timing, bye are the three things. We get synonyms using NLTK. And then what we do is we define intent, create an intent map. So for example, if the user is greeting or saying hello, then there are all these other synonyms that we found for hello. It can be hey, hi, so many other things, so many other ways people can say that. So while not all inclusive, but it does find some synonyms that you can add on to there. So if the user says any of those words, or any of those words occur in what the user's message contains, then you'll be able to identify your intent there. So creating that intent map helps map whatever the user is saying to what they want to do. And depending on what they want to do, if it's a greeting, timing, or exit, what do you want to respond to the user with? So in this case, for timing, we say the store timing, and there's always a fallback condition, which is if the user is not saying hi, not saying bye, not asking for the timing, then what do you want to answer to the user if you're not able to identify what the user is saying? So in that case, we just route the user to call that particular number for more information. So this simple implementation will get you to that basic chat interaction that does not really do anything a lot in terms of processing of the text, but it's a basic functionality, and if that's what works for the use case, then that's great. Moving on, let's look at the AI-based chatbot. So now this is more complicated, and for a more complicated use case. So for example, I want to order a cheese pizza for pickup at 6 p.m. And then the chatbot asks, okay, what toppings do you want? You tell the toppings, the chatbot gets your total for the order and asks if you want anything else, gets a response, and ta-da. So this is more complex, has more components for the chatbot to actually understand. And let's look at what. So I want to order a cheese pizza for pickup at 6 p.m. So one thing here is to identify the intent. The user wants to order a pizza. So when I classify the intent of the user based on their message, and then there's some entities that you need in order to fulfill that intent. So for example, if a person wants to order a pizza, you want to know what time they want to pick it up at, and you want to know what toppings they want. So in this case, from this initial message, I got the intent, we got the time for pickup, but we are missing toppings to place that order. So the chatbot recognizes that and asks the follow-up question, what toppings would you like? And the thing is, people can say it in so many different ways, right? The people can say pizza, please, or can I have a pizza? Can I have a cheese pizza? There are just so many different ways. So we want to be able to capture these different ways of saying the same thing and that point to the same intent. So intents are essentially actions a user wants to execute, and entity are more the who, what, when, where of the things in order to fulfill an intent, such as the times, pizza toppings, if there are other varieties you have, pizza crust, all of that. So there are ways that you can build this. If you want to build your own, it's important to understand that there are different components that play in together to build something like that. So we saw intent classification is important, and the main thing that you'll often find lacks here is it's always going to be around data, or lacking a lot of label data for your use case to start off with. So start off with some sample user messages, create some and write some manually, and you can train a basic bag of words classifier to get that intent classification going on. And then you want entity classification. Now there's some NER, which is named entity recognition models that are available pre-trained from Spacey and NLTK. separately. So you can use either one of those if the entities that they offer satisfy your use case. If not, you can also train your own custom entities using Spacey. So again, start with the basic set of examples and train a model. And as you get more data, you can fulfill that.
We have about 4 minutes remaining.
Got it. Thank you. And then once you have these information, you want to query your database, fetch any information like order total. And through the process, you want to maintain a state or a context of the conversation. So you want to know what is the user's response. So the user is saying no. When you ask a question, would you like anything else? It's about not needing anything else and not about, no, I don't want to place an order. And then also response generation is an important factor. So once you are able to understand, what do you respond to the user with? Everything we spoke about can be summarized in this little chart right here. So you have a previous action that and the current state with the user message that you need to go to your models, your systems, or your databases that help determine the next action, update the state of the conversation, and generate a response for the bot. Now, we spoke about all these components, and it's just not about your backend or your NLP solutions. It sounds like a lot of data engineering as well to add all the components together and make sure that works seamlessly. So if anybody is interested, there's actually a lot of hosted solutions available for chatbots, like Dialogflow for Google, there's Lex for Amazon. So, if you're actually subscribed to any of the services already, if a business is subscribed to any of these cloud service providers, it just may make sense to start off with a chatbot that they offer. So for example, Dialogflow is a really easy way to create a custom conversational AI bot, and it can happen pretty quickly as well. So the same principle, you will just add some manual sentences there, and it'll actually generate the model for you for entities, for intent classification. Now there would be limitations. Maybe there's some cases it may fail in, some cases it may do well in. So, but that is a great option to start with. Another good option if you want to actually build your own is using Rasa, which is an open source machine learning framework. If you don't want to get logged in with a vendor, this is a great option. If you want to also create your custom models for entity recognition, for intent recognition, you can do that and plug into Rasa. And essentially, you can then deploy your model in a lot of different integrations and like Facebook Messenger, whatnot. So it essentially builds the framework for you. And you need to understand how chatbots work in order to use this properly. Another example is the Chatterbot library. Now, if your use case is more like sequential, if you have a message, previous histories of how people respond to that, and you have a new message, you just find the one that's similar to the one and see the response that it generates. So it's more machine learning based conversational dialogue, and you can generate responses based on collection of known conversations. I've attached some reading resources here in case anybody is more curious about these chatbots and look at some research around the topic. Thank you all so much. It was a pleasure talking about this topic.